Okay, the goal for today is to write the equation for a piecewise function given its graph. The piecewise function that you see here are two parts to linear functions. What I've done is I labeled one of the pieces piece 1, the other piece 2, so that it's easier for us to talk about how to write the equation for each piece. Since I have two linear functions, what you'll notice on the graph is I've labeled the ordered pairs. I picked two ordered pairs for piece 1 and two ordered pairs for piece 2. And basically all we have to do is write the equation for the line for each piece and then identify the domain for each piece. If you take a look at piece 1, to write the equation for the line, first thing obviously you have to do is find the slope. And when we calculate the slope using the formula for slope, I got the slope of piece 1 to be -1. What's also nice about piece 1 is the ordered pair 0, 12 is the y-intercept, so we don't have to algebraically find the y-intercept because we see it graphically. So the equation for piece 1 is y equals -x plus 12. I'm going to do the exact same thing for piece 2. I used the two ordered pairs to calculate the slope for piece 2, and the slope was 1. This one, we do not graphically see the y-intercept, so I solved it algebraically. I chose to use the ordered pair 12, 14 along with the slope, and I substituted it into the slope-intercept form and solve for b. So the y-intercept is the ordered pair 0, 2. When we write the equation for that particular piece, the equation is y equals x plus 2. So these are the two pieces we're going to use, or the two equations we're going to use to write the piecewise function. Now what we have to do is identify the domain for each piece. There's two ways to do this because they share a point. If you look at the first piece of -x plus 12, you could see that all the ordered pairs have values of x in them that are less than 5. And for the second piece, all the ordered pairs have values of x that are greater than or equal to 5. Now some of you may be wondering, how did I know to put the equal to part with the greater than sign versus the less than sign? Since they share the same ordered pair, it can go with either. So if you notice, I can also write the equation as -x plus 12 if x is less than or equal to 5, and x plus 2 if x is greater than 5. If you put the equal to sign with both of them, you're violating the rule for a function, so it can only go with one. Which one you choose depends on you.